Hello, my dear students, and I want to briefly cover, in my absence today, since I have to go to the dentist, our material and review our material, the vocabulary, and some of the concepts with this vocabulary review. If you go to Google Classroom and you look under your assignments, you will see this assignment posted there. I've already called it up on my iPad to save us time so that I can go through this material quickly and show you what's expected. So, under Part A, completion, chemists relate units of counting, mass, and volume to a single quantity called the mole. And that mole concept is what we're going to be talking about for the next couple of days. The number of representative particles in a mole of substance is Avogadro's number. Let me see if I can make that work a little better by, instead of writing with my Apple Pencil, just filling it in. Avogadro's, if I can find the possessive apostrophe, Avogadro's number. And to find the mass of a mole of a compound, the scientists add together the atomic masses. Those are the big numbers, frequently red or a different color, in each box of the periodic table for each representative atom. And when you substitute the units grams or grams per mole for atomic mass units or AMUs, you obtain the molar mass of a molecule or a compound. And finally, there are blank representative particles in any mole of substance, and that would be, for us, 6.02, I guess, is good enough, times 10 to the 23rd, times 10, and I can't do superscripts here, so I'm going to use this little caret or carré symbol, 23rd. And that is Avogadro's number. So let's go through these quick true-false, conditional true-false questions. A mole of a pure substance contains 6.02 times 10 to the 23rd atoms, and that would be true if it's an element. But if it is a molecule or a compound, it may contain more, and frequently many more. A represented particle of a compound is the molecule. That's true if it's a covalent compound, but if it's an ionic compound, it might be a formula unit. So there are technically different definitions for what a representative particle can be than just a molecule when you're dealing with compounds. A mole of carbon tetrachloride, so this CCl4 right here, is composed of one atom of carbon and 4 atoms of chlorine. And that is never true because a mole of it would be composed of 1 mole of carbon and 4 moles of chlorine, not atoms. A molecule, a single molecule, would have 1 atom of carbon and 4 atoms of chlorine. And a mole of carbon atoms has a mass approximately 3 times as great as the mass of a mole of helium. And that's, I guess, always true because carbon has a mass of 12 when I go to the periodic table, and helium has a mass of 4. So 12 is approximately 3 times greater than 4. And the molar mass of nitrogen gas. The nitrogen gas we breathe is N2. And it is true that nitrogen gas has a molar mass of approximately 14.0067 grams per mole, but the nitrogen gas we breathe is actually molecular nitrogen, or N2, so it would be 28 grams per mole. So this must be never true. Quickly going through our matching here, if I look at these definitions, Avogadro's number is clearly 6.02 times 10 to the 23rd, and molar mass is the mass of 1 mole of substance. A mole is the international system, or in French, Système International, which would be SI unit that measures the amount of a substance present. So 13 would be D. Oops. Those are little letters, so I will make them appropriately match. And finally, representative particles can be atoms, molecules, ions. Technically, I guess you could have a mole of anything, but representative particles pretty much include those. Explain why we said sometimes true when they said representative particles are a molecule. And so that would be A. Now on these problems, I started typing them already because they take a while to type. And the question is, how many moles of lead, Pb, is in 9.3 times 10 to the 15th atoms? And we saw up here that 1 mole is 6.02 times 10 to the 23rd. And that's a much smaller number by a factor of, what, 10 to the 8th. So if you do the math here, well, let me tell you how we set this up. You have 9.3 times 10 to the 15th atoms. You write down what you know, and then you use your conversion factor because they are asking you to convert it to moles. So we put moles on top, and 1 mole is 6.02 times 10 to the 23rd atoms. And if you do the math, that means you're dividing 9.3 times 10 to the 15th by 6.02 times 10 to the 23rd. And when you do that and you use significant figures, which it'd have to be 2, so I can only go out 2 decimal points, 1.5, when you use your calculator to do this, times 10 to the minus 8th mole. So let me use my little symbol here. You'll also see that symbol on a TI-84, depending on how you express your scientific notation. This would be times 10 to the minus, if I can find my minus sign, minus 8th, okay? And the units there would be moles of lead. MOL of PB. And that's your answer on the second row. But again, I'll point out to you that says show your work. Then it says, what is the molar mass of ethane? And when I do this, all I do is add up the atomic masses from the atomic table of all of the atoms. Carbon is 12. That's what I wrote. 2 moles of carbon times 12 grams per mole of carbon. And I can put the mole of carbon. I just put per mole there so that it, oops, I can't quite get my cursor where I want it. It still can't. Moles of carbon, to be totally precise. But that would give me 24 grams. And I would add that, 24 grams of carbon to my value over here, where I have 6 moles of hydrogen times 1 gram per mole. If you look in the periodic table, that carbon was 12.0108 grams per mole, and hydrogen is 1.00795 grams per mole, but I think the two significant figures is fine. And that would be 6 times 1 is 6. And if you want the molar mass of ethane, it would be equal to 30 grams per mole. 24 plus 6, 30. And our units would be grams per mole. And that's your answer, 30 grams per mole. On the next one, it says find the mass of 3.65 times 10 to the minus 2 moles of potassium sulfate, K2SO4. And on a test, it would be legitimate, at least if I gave you a table of the polyatomic ions, to say potassium sulfate. And then you can figure out, given our recent experience, the formula, which is K2SO4. Sulfate's always minus 2. Potassium is group 1. It's always plus 1. One thing I did was right here, I went ahead and calculated and wrote down the molar mass of potassium sulfate. Potassium is 39.0938 grams per mole. But there's 2 of them, so that would be 78 grams. And sulfur is 32 grams. I'm looking at a periodic table right now. Most people say 32.1. It's 32.066 for the accuracy of our table. And oxygen is 16 grams, but you need 4 of those, so you would add in 64 plus the 32 plus the 78, and you get to 174.3. Oxygen in my periodic table is actually 15.9994 grams per mole. But in the end, what we get is a value that is, I'm doing the calculations, looking 636 times 10 to the minus 2. That's not proper scientific notation. Potassium sulfate, which would be 6.36. And that's just it. It's times 1, or 10 to the 0, which is 1. So we don't really need to, for numbers between 0, actually between 1 and 10 at least, we don't have to, or even 0.1 and 10, we don't have to put in scientific notations. Times 6.36 grams of potassium sulfate. K2, of course that 2 should be a subscript, SO4. And for question number 18, our last one now, this is the opposite of question 15 up above, where they asked you to convert atoms to moles. Now they're asking you to convert moles to, not atoms, but representative particles in this case. And so what I would do is write down what I know, 2.5 moles, and I need my final unit in my numerator. So instead of saying 1 mole per 6.02 times 10 to the 23rd, I say 6.02 times 10 to the 23rd per mole. Okay, right here. So when you do the math and you do the total number of particles, you will get 1.5 times 10 to the 2 times 6 is 12, so that's going to raise that one more power, times 10 to the 24th molecules, which is the representative particle for hydrogen peroxide for the molecular compound hydrogen peroxide, 1.5 times 10 to the 24th molecules of hydrogen peroxide, which is H2O2. So however you do it, please remember to show your work and how you set these up so that you don't just copy the answer, but you go through the process to show how these sorts of problems are solved. So, end this in, and I will see everybody in Virtual Monday. And next week, and I will, I'll take this file. I'm not sure how to save it, but I'm going to save it and end the recording session if I can get to it. There we go.